Chapter 1 Real Numbers. Welcome back to my YouTube channel. In the last lesson, we have started the topic revisiting rational numbers and their decimal expansions from the chapter number 1 Real Numbers. In the last video, we discussed some important theorems. Theorem 1.5 and 1.6. They are just reverse theorems. We can just discuss this theorem once again. Then we'll do some exercise questions in this video. If you are watching my videos first time, please subscribe my channel. If you like this video, please don't forget to press the like button and also share this video to your friends. Let's revise the theorems. A number, rational number, has terminating decimal form. Then that number can be written in the form P by Q, where P and Q are co-prime numbers, and Q in prime factorization we can write in the form 2 raised to n into 5 raised to n. That's what we discussed here. And just to reverse also, if P by Q is a rational number with P and Q are co-prime numbers, and Q in prime factorization it is in the form 2 raised to n into 5 raised to m, then we can say the decimal form of this rational number will terminate. Okay, we can discuss how to find the decimal form. Okay, so suppose the question is to find the decimal form of 3 by 40. So I write to 3 by 40. So we want to check, is this terminating or is this not terminating rational number? How we can check it? So you factorize
it can be written in the form.
It can be written in the form 3 by, what is the prime factorization of 40? That's the prime factorization.
2 cube into 5.
2 cube into 5.
2 cube into 5. So it is terminating, right? This is of the form 2 raised to n into 5 raised to n. Right? If it terminates, the next question is, what is the decimal form? What is the decimal form? So to write the decimal form, we want to make the denominator power of 10. Power of 10. So here 2 cube into 5 is already there. So if we multiply, yes,
5 square.
Yes, if we multiply the denominator by 5 square, what will happen? So the denominator will 5 into 5 square will become 5 cube. So 2 cube into 5 cube will become 10 cube.
Okay.
So to balance this, you also want to multiply the numerator also with 5 square. Okay. So what will get 3 into 5 square by 2 cube into 5 cube will come. So 3 into 5 square in numerator will get 75 by 10 cube will come. That is 75 by 1000. That is 75 by 1000.
0.0.
So if you get any question to find the decimal expansion of a question like this, so you just do the prime factorization of the denominator. If it is in the form 2 raised to n into 5 raised to m, you can write the decimal form will terminate. Okay, then you can find out like this using this technique. You make the denominator power of 10. Then simply write the decimal form. Power can be any positive integer, Okay. So it is clear that any rational number which has a decimal form terminating can be expressed in the form P by Q, where Q is of the form in prime factorization, it is of the form 2 raised to n into 5 raised to m. That's what we discussed last. Okay. So in other way, we can simply say, if any rational number whose denominator is of the form 2 raised to n into 5 raised to m, then the denominator can be converted to a power of 10. Okay? Can be converted to power of 10. If the denominator of a rational number is of the form 2 raised to n into 5 raised to m, then the power of the denominator can be converted to a power of 10. Okay, so we can say if P by Q is of the form Q in prime factorization is of the form 2 raised to n into 5 raised to m, then we can convert this given rational number P by Q of the form A by B, where B is a power of 10. B is power of 10 raised to something. Okay, then we can simply find out the decimal form. Any rational number having denominator in the form prime factorization in the form 2 raised to n into 5 raised to m can be converted to another rational number with the denominator a power of 10. Hope it is clear. So next, if the denominator having no denominator q is not in the form 2 raised to n into 5 raised to n, what will happen? If q is not in the form, the decimal form will not terminate. If it is not terminating, what's the method to find the decimal form? You simply use the long division method. For example, 1 by 3. What's the denominator? Denominator is 3. The prime fraction is also 3. Right? The prime fraction of the denominator 3. The prime fraction of 3 is 3 itself. Because that is itself a prime number. There may be question to find the decimal form. So how we can find the decimal form? How we can find the decimal form? Just apply the long division method and find the decimal form. 1 divided by 3, you can put 0. So 9, okay, 10 divided 1. Again 10 will come, and 3, 9, again 3, 3, again 1 will come, and 10 we can make it 10. Again 3, 3, 3, etc., etc. will come. So 1 by 3 decimal form is 0.333. So this is the other case. If the denominator is not in the form q raised to n into 5 raised to m, we can conclude that the decimal form will not terminate. And there is question to find the decimal form. You can apply the long division method to find the decimal form. So one example given here in the textbook is 1 by 7. Look here. 1 by 7 is given here by long division method. 1 by 7, the decimal form is like this: 1, 4, 2, 8, 5, 7, 1, etc. So after 1, for any non-terminating rational number, if the decimal form is non-terminating, at one place it will start repeating. For example, so we said 1 by 3. I'm stopping, okay? One or 2 minutes only. So 1 by 3 we have seen. 1 by 3 you have seen 0.333. Only one digit is repeating. In some other situation, I think 1 by 11 or something.
1 by 11 is equal to 0.090909, etc. In this case, 09, the 2 digits are repeating.
Sometimes maybe 3 digit may repeat. Sometimes 4 digit may repeat. Sometimes only 1 digit repeat, but only after some place. Sometimes, for example, 0.1478, then all remaining digit 333, etc. That's also possible. So in any case, if the denominator is not in the form and 2 raised to n into 5 raised to n, then the decimal form will not terminate and it will be recurring. We can say a term recurring. Recurring means repeating. It will be repeating after some place. And for some example, it will recur from the first place itself. In some situation, after some places, the decimal form will repeat. So to find the recurring decimal place of such rational numbers, you can use the long division method. Okay, so the last theorem you can see here. Not of the form, okay, this is the opposite case. Q is not of the form 2 raised to n into 5 raised to n, where n and m are non-negative integers, then x has a decimal expansion which is non-terminating. If q is not of the form 2 raised to n into 5 raised to m, then the decimal expansion is non-terminating. That means it will be repeating or recurring. Okay, that's all the last topic. That is 1.5. We discussed only 3 questions are here. I think you can do simple question. You try this question, okay?